Welcome to Analytics as Code meets Infrastructure as Code. Why analytics engineering and DevOps go hand in hand. I hope you've enjoyed Coalesce, and I appreciate you being here for this session, whether in person or online. My name is Katie Claiborne, and I'm the founding analytics engineer at Duet Technologies. I'll tell you a bit about myself and Duet, then we'll jump in. I am an analyst turned engineer. The first part of my career was rooted in the world of analytics. I started as a business analyst, working mostly in spreadsheets. From there, I moved to data analysis, using business intelligence tools like Tableau. As we've seen this week with dbt Cloud's visual code editor, these can be powerful tools for learning the building blocks of SQL. dbt introduced me to version control, and that's what opened the door to the world of engineering. There, I've dabbled in DevOps, developing continuous integration and deployment workflows using tools like GitHub Actions, and infrastructure as code using tools like Terraform. It's infrastructure as code and Terraform that I'll be discussing today. Duet is the first provider network for nurse practitioner-owned practices. Our mission is to support NPs in transforming access to primary care. It's an early-stage company, and I have the opportunity to work across that full range of experience and continue to expand it. Coming back to this talk, I'll be focusing on the parallels between analytics engineering and infrastructure engineering by looking at a tool from each trade. For analytics engineering, we'll be looking at dbt, of course, and for infrastructure engineering, Terraform. But why should you care? Maybe you're an analytics engineer yourself, and you're interested in moving further up the stack, continuing to expand your skill set. Maybe you're a dbt Cloud administrator, and you're thinking about how to build a multi-project deployment. Maybe you're an organization leader, and you're considering how to staff for data and engineering initiatives. My point of view is that analytics engineering is not only an entry point to the world of software engineering generally, but it can also be a jumping off point for further specialization in areas like infrastructure engineering and DevOps. So if we've known that analytics engineering can be a bridge between data analytics and software engineering, I'd like to propose that we can take that idea one step further, and that analytics engineering is actually quite compatible with specializations within software engineering, and in particular, infrastructure. This is data ops, and it drives the analytics development lifecycle. Building on this idea, I believe that analytics engineers have the skills they need to solve their own infrastructure problems, such as scaling a dbt Cloud deployment. That's the use case that I'll focus on today. Here's the plan. I will first frame the problem of scaling a multi-project dbt Cloud deployment. I'll talk through solving the problem using tactics from people to process to technology. I'll look at what it means to make an impact by reducing the time that it takes to set up a dbt Cloud project and the cost of maintaining it over time. And I'll wrap up with lessons and next steps. So first, the problem, scaling a multi-project dbt Cloud deployment. And I'm using phrases like multi-project deployment or multi-project collaboration. And if that sounds like dbt mesh, it's because it is. I'm referring specifically to the ability to reference models across projects within this broader collaboration framework that's called dbt mesh. So the business problem. Multi-project collaboration requires multiple sets of cloud resources, and someone, or to tip my hand a bit, something, has to configure those resources consistently. Consider a single dbt Cloud project with the resources up on this slide. it will have at a minimum 2 environments, a development environment and a production deployment environment. It'll likely have intermediate deployment environments too, such as continuous integration for testing code on feature branches, and a staging environment where code changes are initially promoted upon being merged. Each of those deployment environments will have 1 or more jobs. There's probably a CI job that runs as part of the pull request process. There may be a merge job that runs when code changes are merged into the main branch. And there may be an API-triggered production deployment job that runs on GitHub releases. So for me, this problem manifested when I went to set up my very first DBT Cloud project. I've recreated the first couple minutes of that experience in a short demo. So let's watch. All right, here we go. New project. I'm going to call it Coalesce. And I'll specify a subdirectory for it. Ooh, OK. I'm going to need a connection. Let's do that. I'm using BigQuery. Got another name. Ooh, OK. I'm going to need a service account. Let me do that. All right. Here we go. All right, OK, I remember it's going to need 2 roles, BigQuery data editor, BigQuery job user. So I'll grant those 2 roles. Great. Now remember, DBT Cloud was asking me for a service account key, so let me make one of those. OK, got it. Now we can go back into DBT Cloud and upload that key file. OK, I think the rest of these are fine, so let's save. Just, since I'm on camera, delete the local copy of the key. Oops. OK. Now we can go back, select that connection, and test it. Now I granted the service account the roles that it needed, so this test should complete successfully. And it does. Great. OK, finally, I'll connect to GitHub repository. Here's our Coalesce repo. And that's that. Now, even though we ended on the ta-da emoji there, those were really just the first 2 minutes of the process. We set up our development environment, one of the 7 resources that we saw in the earlier slide. The full setup took me about 15 minutes, and I counted over 200 steps. To be precise, there were 225 clicks to configure a DBT Cloud project manually, admittedly with maybe 1 or 2 bells and whistles thrown in. Regardless, think about whether your organization has 5 or 10 or 15 or more DBT Cloud projects. What are the odds that any person or any team can click through each of those steps consistently across every project? And how will you know if they do or don't without going back through and clicking again? That's the problem in front of us. How to set up and maintain many DBT Cloud projects in a way that's sustainable. Let's talk about tactics for solving the problem, beginning with people. I think organizations should give analytics engineers the opportunity to extend concepts they've learned from DBT. More specifically, I think that integrating analytics engineers into a DevOps function is the most efficient use of an organization's human resources. I'm not saying that analytics engineers can solve all of these problems on their own, but I'm also not saying that teams need to hire or borrow a DevOps engineer to support their analytics engineering function. Instead, I've seen organizations be successful by embedding analytics engineers into a DevOps function. Analytics engineers bring an understanding of the problem they're trying to solve, And as we'll see, they bring a skill set that's transferable to infrastructure, even if the specific tools may be new to them. A DevOps team provides an organization-level framework within which analytics engineers can contribute. They offer guidance, best practices, and standardized workflows. In terms of process, I'd encourage teams to stick to the rule of 3 and optimize at the right time. The rule of 3 tells us that the right time to optimize a piece of code is the 3rd time we've repeated it. The graph here shows 3 different approaches to minimizing the time that it takes to set up a dbt cloud project. The first approach, the red line here, takes the tack of trying to optimize from the very start, the first project. But at that point, teams probably don't know enough to optimize. They'll likely waste time building features that they wind up not needing and fail to build features that they do need, which will cost them down the line. A second approach, in purple, is to simply not optimize. Teams can stick to the manual setup process, and sure, they'll get better at clicking through the steps from project 1 to 2 and 2 to 3, but those improvements will diminish over time, and teams will defer the cost of higher maintenance costs of manually created projects to their future selves. The rule of 3 is the 3rd option, in gold here, and it suggests that sometime around the 3rd project, it might make sense to optimize, to invest in the short term in order to achieve these really dramatic improvements that are also sustainable over time. Finally, technology. I'd encourage teams to use a configuration tool like Terraform to manage their cloud resources programmatically. Next, we'll see just how much configuration tools have in common, even if they cross the lines of disciplines. All right, let's talk about making an impact, reducing project setup time and maintenance cost. Now recall, our goal is to find a tool that allows us to manage dbt cloud resources programmatically. As it happens, just such a tool exists. It's called the dbt Cloud Terraform Provider. First developed by community member Gary James, dbt Labs now maintains the provider. But you might be asking, what is a Terraform provider? And that leads us to the first parallel between dbt and Terraform: plugins. Both dbt and Terraform use plugins to interact with data platforms and cloud providers. In dbt, plugins are known as adapters. In Terraform, they're known as providers. So in your organization, teams might use one or more dbt adapters, whether it's Snowflake, BigQuery, Databricks, any of the others. In Terraform, you can use the Google Cloud Provider, the dbt Cloud Provider, which we'll be digging into, the GitHub provider, the Slack provider. As Benoit pointed out last year, there's a Domino's Pizza provider, should you care to order a pie via API. Once you've selected a plugin, you need to configure it. Both dbt and Terraform need to know how to connect to a data platform or a cloud provider. In dbt, this can vary depending on the product and environment that you're using. dbt Cloud has account-level connections for service accounts, personal credentials for developers, and developers might choose to download those credentials if they're using the dbt Cloud CLI. It's this last option that's most similar to dbt Core's profiles.yamls file. In Terraform, provider connections are configured in the aptly named provider blocks. To configure the dbt Cloud Provider, you need 3 things. First, your dbt Cloud account ID. Second, a dbt Cloud service token. And third, your dbt Cloud host URL. All right, we've got our provider, we've configured it. Now we need to install our source code as a dependency. And both dbt and Terraform include a command for doing so. You may know the dbt deps command for installing packages. Well, Terraform init does the same thing for providers and modules. You can see just how similar these 2 commands are by taking a look at the sample repo here on the left. Have a look at the dbt subdirectory and the Terraform subdirectory. you'll notice that both of these commands install dependency code in folders that should be, at least, ignored by Git. dbt installs code in a dbt packages folder, and Terraform in a .terraform folder. Both commands also generate a lock file to ensure predictable installations. For dbt, this is the package lock.yaml, and for Terraform, an equivalent file. Both commands consider the dependencies that are established in a file like dbt's packages.yaml or in a Terraform providers.tf file. Now we're ready to build. And we'll notice that both dbt and Terraform distinguish between elements that are in and out of their scope, inputs and outputs. So dbt, we know, accepts sources as inputs in order to define models, which are managed within dbt. In the same way, Terraform accepts what it calls data sources as inputs in order to define resources managed within Terraform. Now we're ready to start invoking these tools, and we'll learn that both of them include commands to preview, then execute their planned actions. So in dbt, you've probably compiled a model SQL before running or building that model. In Terraform, you can use the plan command to see the planned infrastructure changes that will take place when you use the apply command. Here's a snippet from a Terraform plan. We see that a dbt cloud project is going to be created. We don't know its ID yet because it doesn't exist, but we know it will have the name Coalesce. With each invocation, dbt and Terraform produce artifacts. And these artifacts describe their state at a moment in time. So you may be familiar with dbt's manifest.json file, which contains a complete representation of a project. It lists each node, the attributes of that node, and the node's relationship with other nodes. Terraform produces a .tf state file, which contains a representation of a configuration. That's like a dbt cloud project, or a dbt project. Again, each resource is listed. Here's the dbt cloud project that we saw the plan for earlier. It has an ID now because we've created it, and the name is as we expected, Coalesce. Everyone's favorite, graphs. We're basically building graphs with both dbt and Terraform, and both tools include a command for visualizing the relationships between these elements. dbt has the docs commands to generate and serve documentation, including the lineage graph. The Terraform graph command does something similar, albeit not quite as pretty out of the box, but same idea. Finally, state comparison. Both dbt and Terraform can and do limit their execution to changed elements. You may have bumped into dbt's state method if you use slim CI. It's a way to build only the models that you've changed, and optionally their downstream dependencies. Terraform limits its scope to changed resources by default. This is because while it's generally okay to run queries over and over again, infrastructure doesn't always take as kindly to being created over and over again. All right, this has been a fun game, but you might be wondering at this point, how can these parallels help us scale a dbt cloud deployment? The answer is that each resource in a dbt cloud project can be configured in Terraform. So coming back to our example project, there's a dbt cloud environment resource that we can use to configure environments, and a dbt cloud job resource that we can use to configure jobs. This means our sample repo might look something like this. We could have a .tf file where our dbt cloud environments are configured, another where our jobs are configured, and a third for project-level resources. But even this approach has its own risks. We can still repeat ourselves in code. Imagine an organization with many dbt cloud projects, each of which is associated with a code repository. One option would be to just copy and paste these files from repo to repo as new projects spring up. But if we're a centralized governance team, we might find ourselves in trouble if we need to change something about the way that all of our dbt Cloud projects operate at our organization. We need to go into each and every one of these GitHub repos and apply that change in the exact same way and somehow validate that we've done so. Not an easy task. This brings us to the most important parallel between dbt and Terraform, and that's that they both offer mechanisms to avoid repeating yourself in code. In dbt, we know that macros serve as functions, accepting arguments for flexibility. The dbt documentation site uses the cents to dollars macro as a simple example. Given any input column, it'll convert the values from cents to dollars. In Terraform, modules provide a way to create multiple related resources. So the snippet here shows a way to configure a dbt Cloud project, not by configuring the individual resources within that project, but instead by calling a dbt Cloud project module, which is like a package containing all of the resources that a project needs to get off the ground. Just like macros, you can pass in variables. Here we're passing in project name as a variable because we want this project to be named Coalesce. In this way, an organization can define in one place the way that it wants its dbt Cloud projects to be structured generally, while still providing enough flexibility for teams to configure certain elements of their own projects. Each team can then call this module in their own repository. Let's take a look at creating a project with Terraform. I've torn down the project that I created manually, and I'm going to recreate it with Terraform's apply command. Right, I'll confirm that I do indeed want to create it. And Terraform is going to tick through each of the resources included in the module that I'm calling in the open file up at the top of the editor here. So it's a little small, but we're creating Google service accounts and keys, just as I did manually. The keys do take a few seconds. Okay, there we go. Boom, done. Okay, let's hop back in. Shazam, a dbt Cloud project. Okay, looks good. It has environments, environment variables, and jobs. Everything we need. That was about a minute. That was half the time it took to set up the first part of a dbt Cloud project manually, but here we have a fully featured one that we've created programmatically. All right, let's wrap up with lessons and next steps, starting with impact. By treating our dbt Cloud infrastructure as code, we solved for both project setup and project maintenance. We reduced the setup time from minutes to seconds with our project in a box. That may not seem like a lot, but if you're building out a dbt mesh framework, it might not always be clear where the lines should be between projects. And having an easy way to create and tear down projects to adjust those lines can come in handy. More importantly, we've established a central interface where we can maintain any number of projects in a way that's consistent and transparent. So lessons and next steps. I hope you take away the idea that analytics engineering can be a solid foundation for diving into sub-disciplines of software engineering. Within that idea, I've learned that configuration tools are everywhere. Once you start looking, you'll see them in areas as diverse as analytics, infrastructure, and continuous integration and deployment. I've also learned to approach new engineering problems with confidence, and I'd encourage my fellow analytics engineers to do the same. You know more than you realize. For me at Duet, I've been working on overcoming my fear of Python and delving into new parts of Google Cloud Platform that I haven't worked with before, like Cloud Run functions. I've listed a couple more resources here because the truth is you don't have to jump straight to Terraform. There are a couple of ways to take more gradual approaches. One of those is dbt jobs as code. That's a way to configure dbt cloud jobs in YAML files, which may be more familiar. There's also dbt cloud terraforming, which loads existing dbt cloud resources into Terraform code. All right, might have a few minutes for questions here, but there's also a GitHub repo for this talk, which I'll share. You can email me, reach out on LinkedIn, or dbt Slack. That's it. All right. Got a few minutes for questions if anyone has them, or I'll be up here as well. Sorry? Oh, back, yeah. Mm-hmm.
Great presentation, first of all, thank you. My question is, so I think this focus on the project setup side, is there any other use cases for Terraform that we could use for dbt other than project setup?
Yeah, definitely a great question. So in addition to project setup, the main use case that I see for this approach is project maintenance. So really, if there's kind of a central data team that's responsible for how dbt is used at the organization, having this centralized module is a way to quickly roll out new features or changes to all of the other teams at your organization that might use dbt. Rolling out a new feature and update can be as simple as them updating the version of the module that they're calling. So that can come in handy.
Do you have an example of how you use Terraform to set up different environments? So if I have like a staging or production or even CI environments, how can I use Terraform to target those different environments?
Sure. And that's in dbt cloud specifically? Yeah, OK. So using Terraform to set up different environments in dbt cloud, there's a specific resource that's called dbt cloud environment. So that's what you'll use specifically to configure it in Terraform. These are newish, but there are also account level connections. So that's another resource you'll want to use. And here in this example, I had kind of a different Google Cloud project for each of my dbt cloud environments. So you can also connect the environments in that way.
Does dbt cloud terraforming fetch the existing environment into a TF state file, or does it generate all the Terraform config files?
Oh, the package that I mentioned specifically, this one?
Yeah.
dbt cloud terraform?
Yeah.
That's a great question. I confess I haven't actually used it myself.
Okay.
My understanding is that it would set up a way to easily import infrastructure that you've already created and kind of generate the Terraform code associated with it, as opposed to writing that by hand.
Are there any resources you would recommend for folks who are brand new to Terraform and want to dive in and learn as a beginner?
Great question. I was new to Terraform myself. I just knew it as the thing that data engineers changed when they needed to give me permissions to things. But the documentation is outstanding, just like dbt. So each provider has its own documentation site where each resource is described. So I think that's been the way that I've learned the most. And really one of the lessons for me is that kind of coming back to the idea that we know more than we realize, I still have this initial jolt of fear when I see a problem that I haven't encountered before. But really, if you've used dbt, you've learned how to learn. You've learned how to read documentation and figure it out, whatever it is. So Terraform is really no different. that's my time, but I'll stick around and answer more questions if you have them. Thanks, everyone.